Hi, everyone. Looks like a lot of participants have come back for the second night, so that's very reassuring. I just want to check that you can hear me, and then I'm ready to start. So if you can type a Y or something. I learned a lot of things last class. One is there's a little bit of a delay. So I guess there's a little delay till you hear me, and there's a little delay till I hear back from you. So I've learned to be a little patient about that. The other thing I learned is I needed to upgrade my chair. I got kind of uncomfortable last time, but that sort of messed up the whole, look for where everything was. So I wanted to say just a couple things before class, and then talk about the material itself for what'll be about 90 seconds. And then I think we're ready to start looking at exam questions. It's something special about this chapter that it doesn't take a lot of preparation. So first, I failed to record last time, mostly because I was dealing with the other details for the first time. I'm trying to record about 3 different ways this time. So hopefully tomorrow, if a person or two missed tonight, or if you'd like to see it, I can get the entire class recorded. And that way, if there's a part that didn't make sense or went quickly or something like that, you can look at it. Although I guess you can record as well. So I'm trying to record, and I just want to say that questions and comments anytime are super welcome. So I'm used to my classes, students. So questions, comments, super welcome before, during, after class. Okay, so it'll feel like interrupting because I tend to talk, fast and kind of nonstop. But please feel free. I'll stop wherever I was and think about what you're asking and either try to answer or say I'll get back to you. And then I have a question for you at the end of class. So I just want to remember that. Okay. So unless there are some thoughts or questions, I'm going to talk for 90 seconds about this chapter. So it's interesting because I can see the delay on the screen that captures my image, or the image of me. So what's special about this chapter is there are very few concepts. Okay, so that's kind of nice. Whenever I got one of these questions when I was taking what was called the life contingencies exam back then, I was happy because I knew if I was careful, if I paid attention to detail, I'd get it right. It's really sort of doing an FM question again with some survivorship thrown in there, or salary scales in this case. Okay, but offsetting that is the unfortunate fact that there's a lot of attention to detail. So we have to be really careful, especially with exponents. Okay, for me, the exponents on for salary increases over time, I always have to sort of get it clear again in my mind what's going on there. Okay, and there are just a few other things that we'll figure out by doing some problems, but I think there are probably a couple of you who've come tonight, I know one person, who haven't really looked at retirement benefits yet. And I think you may be surprised after we've done a few questions. You may be thinking, is that really all there is to it? And after we look at these exam questions, the answer is almost. I mean, this chapter, the textbook that's on the syllabus, has a bit more than have shown up on the exam in the past, and we'll look at a couple of those concepts if we have time at the end. But really, these questions are pretty straightforward if you're careful with the details. Okay, so unless there are comments, I'm going to suggest that we look at the first one. Okay, so let's see. So here's the first question. So a pension plan offers career average retirement benefits. So you have to know that means the retirement benefit. Whoop, that's number 4. Okay, Russell has entered a defined benefit pension plan on January 1st, 2000 with a starting salary of $50,000. That wasn't a bad salary in the year 2000. And we're given facts that his annual retirement benefit is 1.7% of the final 3-year average salary. So we need to be able to figure that out. And his normal retirement date is December 31st, 2029. So we can tell that's after 30 full years of service, since he starts on 2000. And there's a reduction in benefit of 5% for each year prior to his normal retirement date. And when I see that, it's unclear to me what it means. He's going to retire in 2026. So he's retiring 3 years early, and I always wonder, does that mean 0.95 cubed, or does that mean we take off 15%? Somewhere in the notes, the SOA says it's the easy way. It's just 5% per year that he's early. Okay, and we're told that every January 1st, employees receive a 4% increase in salary. So all you have to figure out, no expected present values. You just have to figure out Russell's annual retirement benefit. And I think the first day you started studying for LTAM, you possibly could have gotten this question correct without learning anything else. So I'll give you some time to think about it, and when you punch in some answers, I'll talk about how I did it. I got a different answer than Michael. Maybe these are harder than I thought. What makes these hard is the attention to detail. It's unfortunate. I think Michael got a little unlucky that whatever slight error was made led to one of the answers. Because I can tell what they did here. They have what they think is the correct answer, and then they just went 3,000 in various directions from it. So maybe I can ask first, just what's the final 3-year average salary? So final 3-year average salary. Okay, and the way I get to that is I need the salary, so we need to think about, they started in 2000, so we need the salaries for the years 2024, 2025, and 2026. And now I can never remember, so the final 3-year salary, I know it's going to be the salary in year 24, plus the salary in year 25, plus the salary in year 26, where year 0 is the year we start with, divided by 3. So I just need to think about what these 3 salaries are. Well, S24 should be the salary in the year 2000. And then times, since salaries increase 5% every year, it should be times 1.05 to some power. And I know that power is around the number 24, but I'm never sure. If in 2024, is it 1.05 to the 23, to the 24? But I can check in the year 2001, the salary should be 50,000 times 1.05 to the 1. Oops. Oh, salaries increased 4%. Thank you. Thank you for speaking up. Yay. Now it feels like my classroom. That's good. So as you'll see, I make mistakes occasionally. Okay, so 1.04. And since in 2001, the salary should be 50,000 times 1.04 to the 1, it's clear by the same logic in 2024, it must be 1.04 to the 24th. Okay, so that tells us that 3-year salary, okay, so the average 3-year salary at the end should be 50,000 divided by 3, since we take the average of all 3, times 1.04 to the 24, plus 1.04 to the 25, plus 1.04 to the 26. Okay, so that final average 3-year salary I got is 133,360. Okay, and that's in 2029. I know that seems like a good salary now, but by 2029 it'll be peanuts. Okay, and then the annual benefit, we're told, is 1.7% times the final salary, so 0.017 times that final average salary, 133,360. The university where I work, the formula is almost exactly like this, and many of the professors take on extra work in their last 3 years to pump up that salary to something closer to 133, so they can have a more pleasant retirement. But anyway, that's times 27, the total years of service. That's one place to go wrong, because we stop at the end of 2026, but we have to remember that means we did all the years 2001 to 2026, which is 26 years, and the year 2000, which is 27 years. Okay, and then there was a reduction of 15%, so we have to go down, we have to multiply that by 0.85. Okay, so we multiply this whole guy out, and I got 52,030. and that was one of the answers, so I stopped. But it could be that Michael's right. So I guess I'd like to know: did others get 52 or 55? 52. Okay. So at least one person's on the same page. Okay, good. So two is enough that I feel very confident. So any questions about that one? I hope you see what I mean, that it's really logic and FM with a little survivorship thrown in. But this example actually doesn't even have survivorship. We really hope to see this question on the exam, and we want to be careful with the details because we know we can get it right. It's not like it's some weird concept like common shock where we have to know something arcane. Okay, let's try, unless folks have questions, we can try number 2. Okay, same idea, but a little bit harder. See if I can make this a little uncrooked. There we go. All right, I'll let you work on this for a minute. Oh, and I just realized it may be a good idea if you give up. It might be a good idea to type GU, or we could just be waiting at a point where everyone's given up. So that would be, that would be sad. Oh, one person. Oh, we've had multiple calls for help. Okay, so when I look at this problem, so the first thing I do, this is just when I'm trying to answer the questions, is I look out for the things I get wrong. So the first thing I notice is this new employee starts at age 45 and the employee retires at 65. So I just have it in my mind that they're going to be 20 years of service. Okay, just otherwise I end up messing up and just put in 35 because people often work 35 years. But here's what we want to do. So first, we have 2 different benefit plans. It looks like a question right out of a textbook. We actually learn something here about how defined benefit and defined contribution are related. First, we have a defined benefit plan, like the one we just calculated, and we want to arrange so that the actuarial present values of the defined benefit plan and the defined contribution plan are exactly the same. Okay, so first we want to find the EPV is the new abbreviation of the defined benefit plan. So I'm going to find EPV, and then we'll work on X. Okay, so for the EPV, we first need to find the 3-year, so the final 3-year average salary. Okay, and we know that that's the salary at age 64, and we have exact ages here. That's kind of handy. I notice on the exam we always have exact ages and exact years, or very often, and in the textbook it's half years a lot and quarter years and that kind of stuff. So it might be, I don't know, I see a question coming on the exam where we have to deal with a non-integer age. But anyway, or non-integer number of years. But the salary at age 64 plus the salary at age 63 plus the salary at age 62 divided by 3. And then we know that that's equal to the starting salary, and I'll pull that divided by 3 out front. And the salary at age 64 is the starting salary times 1.05 to the 19th, right? There are 20 years. The first year it's 50,000. So in the 20th year, it's going to be 50,000 times 1.05 to the 19th, okay? Plus 1.05 to the 18th, plus 1.05 to the 17th. And then we're very careful with our calculator working that out, and we should get, I got 120,426. Okay. So that's the final 3-year salary, and then the annual benefit. So this is all under the defined benefit pension, okay? The annual benefit we know is 0.015, 1.5% per year of service, times that final 3-year average salary, $120,426. And if you multiply that out, you get, I got $36,128, which that annual benefit's not that great when you think the final 3-year average salary was, $120,000, but they only worked 20 years for that company, presumably they have pension from their job before that. Okay, so that's the annual benefit. So to get the actuarial present value, or what's now called the expected present value of that benefit, we know it's that annual payment amount, $36,128. Ooh, I hope payments are annual. Annual annuity due. Yay. Okay. I thought it was going to be hard, but luckily, even harder, I should say. Times an annuity due starting at age 65. And we're told that value is 10, so the actuarial present value is just $361,280. So that's what we want to match with the defined contribution plan. And when I look at the defined contribution plan, it's not obvious what's going on. To figure out what's going on, I know that each year we're going to contribute X percent times the salary, right? And in the first year, S sub 45 times X percent, that's just 50,000. We know that accumulates to. It's going to accumulate for 20 years. Accumulate. Okay. I thought my spelling problems were related to using the blackboard, but I can tell it's just as hard on an iPad. Okay, but this accumulates to just that contribution for 1 year. So X percent is X divided by 100 times 50,000. So it's going to accumulate to 50,000 over 100, or 500X. That's the number of dollars put in that year. So 50,000 times X percent, 50,000 times X over 100. That'll accumulate for 20 years times 1.05 to the 20th. Okay. Plus, in the next year, S45, we're going to contribute more because our salary is going to have gone up by 5%, but it's going to accumulate for 1 fewer years at 5%. Okay. So what's interesting, we can see that for all 20 years, what we're accumulating to is 500x times 1.05 to the 20th. So the total accumulation, the total will accumulate to, let's see, that was 500x times 1.05 to the 20th. The salary increases are exactly offsetting the fewer years of accrual, times the 20 years of contribution. So let's see, 500 times 20 we know is 10,000. So 10,000x times 105 to the 20 has the equal that EPV for the defined benefit plan, 361,280. And we can divide both sides by 10,000 and divide both sides by 1.05 to the 20th. If we do that, we'll get that X is equal to, I hope you can still see this. Yep. X is going to equal to, I got 13.62. So I guess that's E. And at least one other person got the same thing. So this is like a really good example, I think. We don't have to know a lot, but the details are tedious. We have to be careful with each part. This is really sort of 2 questions, right? And I know whoever wrote it felt like they were being clever, forcing us to think about defined contribution and defined benefit. But I hope this says they need to say specifically actuarial present value at age 65. Oh, they do. Okay. All right. Well, shall we take a look at 10.3? Okay. So here's Bob. And I'll let you look at this question about Bob without me giving input for a bit. And let's see. That's very close to what I got. That's $4 from what I got. So, and I have problems with rounding. So which answer is that pointing to? That's pointing to, I guess, E. Well, I guess it's a good time to talk about it. So first thing I need to do is write down the number of years of service. And I have to be careful because there's a 40 here, a 35 here, and a 65. So we're just going to have to be careful about salaries and number of years of service. But he started at age 35. He's 40 now with a salary of 50,000, and he works to 65. So N is going to be 30 years of service. Okay. And we have to calculate the defined contribution plan accumulation to get his total annual benefit up to $42,000. Well, all we have to do is find what the annual benefit is, and then subtract that from $42,000. And to get the accumulated value at that time, we'll just have to multiply that by A.65. Okay, so first we need the final 3 years of salary. S40 is 50,000, and we need let's see, final 3 years. So the final 3 years so he stops at exact age 65. So he never works at age 65. So we need his salary at age 62 plus salary at 63 plus salary at 64, all divided by 3. So we know that that's going to equal 50,000. His salary today. Now we have to be careful not to use 30, but to use 25. Over 3, I'll pull that 3 out front, times 1.04. Okay, so he's 40 now. Salary 62 should be 1.04 to the 22nd, okay, plus 1.04 to the 23rd, plus 1.04 to the 24th, okay? And if we, wait a minute, we need to, that's his final 3 year salary, and that turns out to be not very large. I don't have that number, but his annual benefit, so let's go ahead and get that. Since I just said we need, I could be needing the annual benefit, is that 3 year salary times 0.005. Wow, what a miserly employer. That's a terrible benefit. You should quit well, I don't want to tell anyone to quit. Okay, times number of years of service, which will be 30 at that time. Okay, from 35 to 65. Okay, so 0.0005 for each year of service times the final 3 year average salary. And if you work all that out, I got that the annual benefit is $11,828. Okay, which is not very much, right? This is less than $1,000 a month. Okay, so that's kind of an unhappy amount. I don't know why Zoom didn't pick that up. There we go. Okay, so we want a benefit of $42,000, so we have to make up, or Bob will have to provide, 42,000 minus 11,000. Whoops. $42,000 minus 11,828, and that's almost 12,000 there. So it looks like that's equal to 30,000. What? 172. Hope that's right. I'll check. No idea. Okay, and so the EPV at age 65 of what we have to make up with the DC plan is going to be that annual amount that we want to provide, 30,172 times A.65. A.65 is given to us as, 2%. Oh, 2% is the rate of salary increase. That's too bad. Yeah, these guys. So you can see that when I take the exam, I would get an answer like completely wrong, right? I'd have to go back and find the mistake, which you found for me. And luckily I worked the question before class. And so the 11,828 is correct, I think. But we'll have to provide 30,172 per year. So per year. So thanks Corinne and A07 for pointing that out. This is going to be 30,172 times 9.9, and I got, like I said, 298. $703. Now, I should tell you, it looks like I have bad handwriting, and I'd like to blame that on the iPad, but in fact, I have terrible handwriting. So, anyway, and so I'm going to go with E. Now, I'm a little surprised. It's not closer to 300,000. Did other folks get Oh, well, I know Michael did around the same number. So the rule of thumb, so this may make you wonder, how far away should you worry that you've done the problem wrong? I worked for ETS a lifetime ago, back in the 90s. And our rule of thumb was we could never be more than a third of the way from one answer or one option for an answer to another. So if I had gotten something here like 296 or 296.5 or 296 500, then I would worry. I would assume I'd done the problem wrong, and I need to go back and do it again. But really, that 299. It's not even 299. The answer should be 299, 279, 259, and then it would be a better question. All right, my other numbers were right. Thanks. Good. All right, you can give 10.4 a try, and when they start get boring, well, no, we hate to think they would ever get boring. Just think of that pay increase when you pass the exam. Okay, so first, what are the key words that make this a lousy pension? I mean, there's sort of two words, and those words sort of are what make the whole problem go. Is why I'm asking about it. Because I was, at first I was excited, right? 2% per year of service sounds great, right? But then I realized it's actually terrible. So what are the two key words that make this pension not so good? This is the bonus prize. So this, if I could get you $5. Oh, well, there's PayPal today. Okay, no, yeah, career average. That's it. That's the problem here. Especially if there's any kind of inflation, a retirement benefit that's calculated on your career average salary is really terrible. And even not with inflation, because salaries go up over time, so that people who are older can I'm not sure why they go up over time, but they do. Okay. Anyway, all right. So the first thing we want to do is we want to calculate his annual pension, just the annual benefit. So we know the benefit is 0.02 times average salary for, I forgot to do N. So he started 2014, stops in 2044, and is 30. That's just because I'll get the answer wrong if I don't do that. Okay, times his average salary times number of years of service. Okay, which is 30. So you can see what I noticed I needed in. Okay, so the trick here is we have to find the average salary, right? So the average salary, I'm just going to write average. We know it's the salary he started out with, so $45,000, plus his salary the next year, $45,000 times 1.04, plus, and so on, right, with higher powers of 1.04. So that average is equal to 45,000. Oh, wait a minute. It's all of that divided by 30, okay? So that average is 45,000 divided by 30 times the sum as k goes from, 0 to 29. There are 30 years. I've covered all 30 of 1.04 to the k, and that's the average salary. Now, you may have noticed or not that these 30s are going to cancel out in a minute. The 30 here, I should maybe change color there. You may have noticed that the 30 here and here are going to cancel out, but that's not important, right? I mean, I guess it is important, but we can work with the 30. It won't matter, okay? So this is 45,000 divided by 30 times an annuity due, an annuity certain of 30 years. So this is, of course, FM, evaluated at 0.04. Now, I would evaluate this on my trusty TI actuarial science calculator, whichever one it is, the BA something or other. But you may remember, if you're one of the fancy math folks, that, let's see, 45,000, 45 divided by 3 is 15, so that's 1,500. 1,500 times, a way to calculate that guy is 1.04 to the 30th minus 1 divided by 0.04. And if you're really good with geometric series, you can, sort of derive that quickly, but I don't know. I'd rather use a calculator. And that turns out to be 84,127. These particular skills, by the way, of evaluating things like A30.04, if you're doing actuarial work, well, I guess all of you are. They're completely useless now because you use a spreadsheet for everything like that. But anyway, okay. This is the average salary. So the annual benefit that we're trying to calculate, the annual benefit is equal to 0.02, whoops, 0.02 times that average, lifetime average salary, 84,127 times 30. And we could have saved ourselves a little calculation by dealing with the 30. But that annual benefit turns out to be, I got 50,476. So Michael and I agree exactly. So there's a chance we're both wrong. All right. I'll give you a chance to do 10.5, and then we'll do one of the harder textbook problems that I feel like something like them is coming, but I could be wrong. So I'll let you work on 10.5 for a minute. So I think this is the best question in the list that we've done so far, except perhaps the one that compared defined contribution to defined benefit. Because here, we're actually, as a company, trying to calculate the actuarial present value or expected present value today of a retirement benefit for a current employee. So, and we're not told how many years the employee is in the plan. We're told that right now they're 55, and that the benefit is 0.0175 times total earnings during years of service. And their current salary is 50, but we don't know what their salary was in the past or how much they made. We're told salary increases are 3% per year. Aha. And we are told we don't have to worry about past years because total past earnings are $525,000. So since it's 1.75% of their total earnings, I see. So there's no multiplier for years of service. So for once, we don't need to know N. You can see when I first saw this problem, I kind of panicked, right? Because my first step is always to find N, and we don't get to know N, the number of years of service in this problem. So we can tell the annual benefit is equal to 1.75%, 0.0175 times total earnings. So total earnings are going to be 525,000 plus, and we'll just put this right there. Future earnings are going to be 50,000 plus 50,000 times 1.03 plus 50,000 times 1.03 squared, etc. So that's 50,000 times the sum as k goes from 0 to 9. I always have to check to make sure they're the right number of years here. So k equals 9, that's 10 years, okay, of 1.03 to the 9th. So this whole thing is going up into that bracket there. Okay, so that's 0.0175 times 525,000 plus 50,000. And then you can use your calculator, or you can use that the summation trick I talked about before, 1.03 to the, I feel like this should be the 10th minus 1 divided by 0.03. Let's see if that's what I had before. It is. Okay. And then if you do that calculation, you get 19,128. And if I were taking the test, the first thing I do is look for that answer and realize, oh, I'm not done with the problem. Okay. So that's the annual benefit. We want the expected present value. So the expected present value today, when he won't be retiring for 10 years, is its value in 10 years, which is the annual benefit, 19,128, times it's a monthly benefit, so A upper 12 sub 65. He'll be 65, or we don't know, he or she will be 65 at that time. And then that's its EPV at age 65, and we need to bring it back to today with interest and survivorship. So we need to divide by, are we given an interest rate? Yeah, 4%. Okay, divided by 1.104 to the 10th to take it from 65 back to 55. That's a not so aggressive interest rate, though. That's nice to see. Okay, times, and in order to get this, are we told they only get this pension if they survive? Huh, interesting. In truth, there would be more obligation than this. Likely, if they die beforehand, someone else is going to get some benefit. But anyway, okay. But we're going to pay this benefit only if they live. I'm assuming that because otherwise, why give me that number? Okay, times 10p55. So we put all that together, and let's see, what's that? 19,218 divided by 1.04 to the 10th times 12.6 is the value of that. 12.6, yep, is the value of that annuity due, and then times 0.925. What we're given is 10p55. Multiply all those together, and we get that the expected present value, and I always have to correct myself. I try to write actuarial present value every time. That's what we used to call it back in the day before, computers and cars. Okay. All right. We had computers and cars, but not internet. Okay. Is 151,320. Okay, is what I got. Okay. Thoughts on that? We have two options for what to do now. I can ask you the question I need to ask you by the end of class, or we can go back and look at exercise 9.2 in the textbook. I think it involves two concepts that I feel like are going to be on an actuarial exam in the near future, even though we don't see it too often. So, question or exercise? Those are your options, Q or E. Exercise it is. We'll save the question. That's very funny. Okay, all right. Okay, so this is Chapter 10, Notes and Problems, and it's going to be 9.2. Before we do the exercise, please take a screenshot of this page, and I'll move it over a little so you can see the whole table there. Take a screenshot of this salary scale. I feel like salary scale is coming, and we just need to get good at it. Okay, so take a screenshot, save it, because we need to know how to use these salary scales. Okay, so I'm going to assume you have that. I've written down the numbers I need from it. But the way this works is these are multipliers. Okay, so the idea is if your salary was If your salary was $50,000 at age 30, the idea is that at age 40, your salary will be 2.005 times that. So what's that? $100 and I don't know, $50 or something. $100,050. Okay. Anyways, okay, so I'm going to assume you have a screenshot of that, and we're ready to go look at 9.2. Okay, so I'll need to move this guy again. Okay, so take a look at 9.2. And then, and there's some confusion. Some things refer. Wow, that really came out looking horrible up there. Okay, are we in chapter 10? Are we in chapter 9? And the problem is when they change the edition of the book, it really looks horrible. I just want to tell you, my screen is beautiful. Okay, let's go back and come forward again. Much better. Okay. When they changed editions of the book, they put in an extra chapter. So what used to be Chapter 9 is now Chapter 10. So this says 9.2, but if you have the paper textbook, it's Chapter 10.2. So I'll let you work. We're just working on Part A right now. So the key here is the 4-year average salary, the final 4-year average salary. So this is the final 4-year average salary equals, so we're going to retire right at age 60. So it's the salary at age 59. I'm going to start at 59 because it makes it easier to count down, plus the salary at age 58, plus the salary at age 57, plus the salary at age 56. And I'm writing it that way to distinguish from S, which is for this multiplier from the table. So it's all of that divided by 4. And now here's the idea. The salary at age 59 is the salary at age 30, so this is 75,000, times the ratio of the two salary multipliers. So 35, sorry. No, all good. Okay, so this is S S59 divided by S35. Okay, and if you look at the table, that's 3.432 in the table I asked you to take a screenshot of, divided by S35 was 1.359, if that makes sense. 35, that's a 9. There. Okay, so that means the 4-year average that we're looking for, it's just going to equal 75,000, and then that, where we're dividing by 4 here, I'll pull that out front, 75,000 divided by 4 times all those ratios over 35, S59 over S35 plus S58, that multiplier divided by S35 plus S57 plus S56. And just to make sure you're pulling the right numbers off the table, I'm just going to write those out. Okay, that it's 75,000 over 4 times, let's see, the numbers are 3.432. We found that just a minute ago, plus 3.382. And I seem to remember these just went down by 0.05 each time, which is kind of odd. 3.332, and the last one also went down by 5. 3.282. Okay, all divided by 1.359. So clearly the pattern breaks somewhere, or S35 would not have a last digit of 5. So if you multiply all that out, you get, or I got, a final 4-year salary of $185,265. Did anyone else get that answer? Yes, okay, isn't S30, oh, did I do S30? That's so unfortunate. Okay, so Peter informs me, let me just go back and look. I bet I did S35. So if I look, S35 is 1.461. Oh, that's just too bad. I guess you can see what I did there. I went and took I took the one just above. Oh, that's a shame. Okay, all right, so let's go look at that guy again. So as Peter correctly points out, this number, so let me put this in red. This number should be 1.461. Okay, so my question for you, give me a break. Oh, I've already saved that page. That's a shame. Okay, so, man, who knows how Explain Everything works. Okay, that this guy should be divided by 1.461. Sorry, I selected the wrong one. So my question for you is, what's the answer then? Because my calculation was based on 1.359. So what's your final answer? $170. Can anyone confirm that? Peter's answer? I mean, I could actually resort to using a calculator, but that would be an act of desperation. I guess that's 331. Yay! Okay, that's 2. All right, thanks, Michelle. Okay, so we're going to go with that. Okay, so we're at 8:10. I guess what I'd like to do, if this were a class, I'd have you try 9.2b and we discuss it. So it's been 70 minutes. You're probably pretty tired. B, I mean, the real thing I wanted to say about part B, I'll just say it now. This is the key to B, just so you know. I won't ask you to do it, but the key to B is you have to find what S sub 54.5 should be, what the multiplier should be for 54.5, multiplier between years, between ages 54 and 55. Okay, and I'll take you back there. The key is just to go halfway between the two, so it's not like rocket science or anything. The key is that when you have to find a multiplier, you want to go halfway between those two. So S sub 54.5 is equal to S54 plus S55 over 2. So you should think of this as the average of the two, but you should think of it as the linear interpolation. So if you wanted the multiplier for 1/4 of the way through a year, you would weight them 0.25 and 0.75. 0.25 times whichever one is farther away, and 0.75 times whichever one is closer. And that's really why I wanted to talk about 9.2b. It's a complicated problem because someone is age 55 right now. Salaries are increased halfway through each year. So that means their salary was actually set back when they were 54.5. So kind of annoying. This, I think, is less likely to show up on the SOA exam, but Part A is coming. Something just like Part A is coming. Any parting thoughts? Oh, I got some comments from email. They were very helpful. They were both kind and helpful, which was very nice. The best kind of criticism is kind criticism. I've tried to work on getting right to exam questions based on folks' suggestions and spend less time on exercises. And then the last thing I need to say is next time is Monday, which is February, oh gosh. Well, tomorrow's Valentine's Day, 18th, February 18th. We're going to talk about the mortality improvement material that is on the syllabus. And this is a strange topic to me because, I mean, I worked in the life industry, and at the company I worked for, which I had to sell out to another company, so maybe this was bad, but assuming mortality improvement was considered a big no-no. They just preferred to be a little less competitive and hide profit in there in the mortality improvement. Thanks for coming. Thanks for coming for the second time. Hopefully the recording works. I think there's a chance there'll have to be 2 recordings, but nice talking at all of you all. Thanks. Have a nice evening. Oh, let me be the first to wish you all happy Valentine's Day. Okay. All right.